Greetings. In this video we're going to talk about the trig functions that we didn't talk about in the last video. So we talked about sine, cosine, and tangent in the last video. In this video we're going to talk about the associated trig functions cosecant, secant, and cotangent. Alright, so let's take a look. So here what we're looking at is we're looking at the unit circle, the circle of radius 1 centered at the origin. The point 0, 0 is the center. And there's a lot of information on this circle. We see the angles, some angles, not all angles, but some angles. The angle of 30 degrees, 45 degrees, and 60 degrees. Remember, these angles are always measured counterclockwise from the positive x-axis. And we also have these same angles in radians instead of degrees. And any angle determines a point on the edge of the unit circle. And what we have over here are the coordinates of that point. And of course we have more angles than just that. We go all the way around the circle with various angles. These are very commonly used angles, and so these are the ones that are labeled here. Of course there are other angles and they have associated coordinates, but these are the ones that we're going to focus on. We have discussed the sine, cosine, and tangent functions, and we talked about what they measure. The sine of the angle is the y-coordinate of the associated point. Cosine of the angle is the x-coordinate, and tangent of the angle is the y divided by the x-coordinate. Now in this video we're going to talk about three more functions. The first one is the cosecant function, and that is defined by 1 over the y-coordinate of the associated point. We have the secant function, and that is defined by 1 over the x-coordinate of the associated point. And we have the cotangent function. That's defined by x over y, where x and y are the coordinates of the point. All right, so let's take a look at some examples. Let's do some review, and we'll compute, for example, sine of 7 pi over 6 radians. So what I'm going to do is I'm going to look at where 7 pi over 6 radians puts us. That puts us here, 7 pi over 6. And remember, if you don't have this circle mapped out, you can always just count. We know that pi over 6 is this amount, right? So I can see this amount of angle I need to cover. That's 1 pi over 6. We have to count 7 of them. So 1, 2, 3, 4, 5, 6, 7. So even without this picture, you should be able to position yourself in the right location. Notice when we count in pi over 6s, we skip these red multiples of pi over 4, right, over here. Those are not multiples of pi over 6, so we don't count them. We only go up by multiples of pi over 6, right? And 7 pi over 6s gets us to here. What is sine? Sine is the y-coordinate. What's the y-coordinate? Well, it's -1/2, and so that is the answer. So by being able to map out this circle, we can very quickly get the answer to these problems. Let's look at cosine of 5 pi over 6. Cosine of 5 pi over 6, well, let's find 5 pi over 6. 1, 2, 3, 4, 5 pi over 6, just like it's labeled. Cosine is the x-coordinate, and so what's the x-coordinate of this point? -√3 over 2. What about tangent? Let's take tangent of pi over 3. Tangent of pi over 3 radians. Well, where's pi over 3? That's right here. You could count that as 2 pi over 6, right? 1, 2 pi over 6. Either way, you find yourself over here. What is tangent? It's y divided by x. So I'm going to take the y-coordinate, √3 over 2, and divide by the x-coordinate, 1/2. When I simplify that, I see I get simply square root of 3. So the tangent of pi over 3 radians is √3. Okay, let's look at cosecant, secant, and cotangent of the same angles here. So if I was to do cosecant of 7 pi over 6, well, we've already computed sine of 7 pi over 6. That's y. Cosecant is 1 over y. So this is going to be 1 over -1/2. And of course, that is equal to -2. What about secant of 5 pi over 6? Well, that's equal to 1 over x. We've already computed what x was. That was negative root 3 over 2. So we're just going to take 1 over that. That is negative 2 over root 3. Now, what people like to do when they report their answers here is they like to rationalize the denominator. And what that means is to make the denominator not an irrational number, as it is now. Root 3 is an irrational number. We want to make it a rational number. In fact, we can make this an integer if we multiply the numerator and denominator by root 3. If I do that, the denominator becomes 3. Root 3 times root 3 is 3. And the numerator becomes negative 2 root 3. And there we go. That's secant of 5 pi over 6. Finally, let's do cotangent of pi over 3. Well, cotangent of pi over 3 is x over y. What we computed over here was y over x. So all we have to do is reciprocate this. So I know that's going to be 1 over root 3. But again, we like to rationalize the denominator, so let's do the same trick. Multiply the numerator and denominator by root 3, and we see we get the answer root 3 over 3. So cotangent of pi over 3 is root 3 over 3. Let's look at some other values of trig functions. Right. Let's take a look at cosecant of pi. What would cosecant of pi be? Well, pi radians is exactly halfway around the circle. That's over here. Now, what is cosecant? Cosecant is 1 over the y-coordinate. What's the y-coordinate? It's 0. So this should be 1 over 0. But of course, we know that 1 over 0 is undefined. And so this is undefined. Sometimes people write DNE. They write does not exist. Okay, let's look at another one. Let's look at secant of 3 pi over 2. What's that? Well, 3 pi over 2, where's that? That's 1 pi over 2, 2 pi over 2, 3 pi over 2. Well, secant is 1 over the x-coordinate. What's the x-coordinate? It's 0. And again, that's undefined. Or does not exist. Either one of those answers may do the trick. Depends on who your instructor is, what they'll accept. All right. Finally, let's look at one more. Let's look at cotangent of pi over 2. Cotangent of pi over 2. Well, pi over 2 puts us here. Right? What's cotangent? It's x divided by y. It's 0 divided by 1. Well, that's totally fine. That is defined. That's equal to 0. So cotangent of pi over 2 is 0. Now, I want to point something out. Notice that cotangent is the reciprocal of tangent. Now, what's tangent of pi over 2? Tangent of pi over 2 is y over x. That's 1 over 0. That's undefined. Right? Now, we need to keep this in mind. Just because tangent is undefined doesn't mean cotangent's undefined. So to compute cotangent, you can usually get away with just computing tangent and then taking 1 over that. But this is an example of where that doesn't work. Because when you compute tangent, you get no answer at all. So you can't take 1 over this answer if this answer doesn't exist. So for certain angles, for odd multiples of pi over 2, like pi over 2 or 3 pi over 2 or 5 pi over 2, cotangent is going to equal 0, even though tangent is undefined. So we have to be a little bit careful. You should always go back to these definitions when you want to be sure about the value of your trig function. All right, so now let's explore the graphs of these trig functions. So let's start by reviewing the graph of the sine function. So the sine function gives us the y-coordinate of a point at a given angle. So let's take a look here. As I increase this angle theta, the value of the sine function is the y-coordinate of that point. So the height of the graph always matches the height of that point as I spin it around the circle. And so as the angle increases, we see the sine function oscillates up and down. And I could really zoom out to see a bigger picture of this. And there it goes. As the point spins around the circle, the angle increases, and the height of the graph is the y-coordinate of the point. And that is the sine function. All right, so this is what it looks like. And you can see it's periodic with period 2 pi, because that's how long it takes for the graph to repeat. If I go 2 pi radians, the graph starts over again. All right, so let's go back and talk about these new trig functions like cosecant. Cosecant is giving us not the y-coordinate, but 1 over the y-coordinate. Now right here, we have an issue. The y-coordinate is 0. So cosecant is not going to be defined, right? Because 1 over 0 is undefined. So the value of cosecant at angle 0, the height of the graph above 0 here, is going to be undefined. But as the angle increases, we are going to see the graph emerge. So let's see. As I increase the angle, there comes the graph. Now why is the graph coming down? Well, because when the angle is very small, I'm taking 1 divided by a very small number, right? Because remember, I'm taking 1 over the y-coordinate. So that gives me a very big number. And so for that reason, the graph is up near infinity. But as the angle increases, the y-coordinate of this point approaches 1. So the height of the graph is approaching 1 over that, 1 over 1, which equals 1. So this graph is going to come down to 1 and then level off. And there it goes. Once I passed 1, now the y-coordinate is decreasing again. It's going back down to 0, and so 1 over the y-coordinate is going to go back up to infinity. And there it goes. You can see that in the graph. It goes up to infinity. Now what happens next? Well, the point is going to dip below the x-axis and its y-coordinate will become negative. So we'll see the same picture, but negative values instead. The graph comes up, we can see it over here, and then goes back down. And if I zoom out to see a bigger picture of what's going on, and I continue to spin that point around the circle, we see the graph is mapping 1 over the y-coordinate of that point. And so what we're seeing in red over here is a graph of the cosecant function. All right, now let's rewind all this, zoom back in, and take a look at the secant function. The secant function, we can already see the left part of it, is 1 over the x-coordinate. Now right now the x-coordinate is 1, and so the value of the secant function is 1 over 1, and we can see that's where the graph is. It is coming down to 1. And as I increase this angle, what's going to happen? Well, the x-coordinate is going to decrease to 0, and so 1 over that is going to increase to infinity. So I'm going to need to zoom out to really see this. And as we increase this angle here, there goes the graph, increases to infinity. Now when I go past 90 degrees, or pi over 2 radians, the x-coordinate of this point will become negative. So now it's going to be negative and near 0, so the graph is going to be near negative infinity. So we should see this graph come up from negative infinity. And there it comes. Now the biggest this graph is going to get corresponds to the furthest left this point gets, because remember, secant is 1 over the x-coordinate. And so the x-coordinate is getting closer and closer to negative 1. 1 over negative 1 is negative 1. So that's where this graph is approaching. And then the x-coordinate goes back to 0, and so the graph goes back down to negative infinity. And if we zoom out a little bit more, we can see this process continue as the angle increases. And what we're seeing is a graph of the secant function. Okay, so we've seen cosecant and we've seen secant. Let's zoom back in here and talk about cotangent. Well, you can already see part of it back here. Cotangent is x over y. Right now, x is 1 and y is 0. So right now, it is undefined because 1 divided by 0 is not defined as a number. Right? But as this angle increases, the point's going to move up, the function will no longer be undefined. We'll be taking some x value divided by a y value that's very small, so the function will be very large. So we'd expect the function to be coming down from infinity. Let's see, we'll zoom out a little bit and see if we can see that happening here. And there it comes down from infinity. Now, as the point approaches this part of the circle here, the x-coordinate's going to 0, and the y-coordinate's going to 1. So x over y is approaching 0. So this line should come down to 0 by the time we get to 90 degrees, or pi over 2 radians. And there it goes. When we pass that, now the x-coordinate becomes negative, while the y-coordinate remains positive, so the graph becomes negative. And as the y-coordinate drops back down to 0, the graph has to go to negative infinity. And as we keep going around, we see this pattern repeat. And so this is a graph. We'll zoom out a little bit more. This is a graph of the cotangent function. We see the cotangent function has period pi. You only need to go pi radians before the pattern repeats itself, just like the tangent function.